Hello students, welcome to today's session. So in continuation with reagent based organic reactions, we shall be placing one more video where some more reagents would be added into your knowledge bank. So here comes the question, let us try to understand this particular problem. So in which of the following reaction would produce a chiral compound as the final product? So here in the question, along with the reagent understanding, you also have to see that do you know what is achiral? Achiral molecule is the one where you would find some sort of symmetry in it. As a consequence of that, it is optically inactive. So let us discuss it that how which out of this would produce a achiral compound. So first let us see what is being given. So we already have placed that this particular video on this the Grignard reagent. Grignard reagent is a sigma bonded organometallic complex. Organometallic complex. So organometallic complex, but the sigma bond which it is having with carbon magnesium is highly polar. So CH3 MgBr. So as and when you happen to use this in any organic reaction, this would always break it like this because this is delta positive, this is delta negative. So this is nothing but a source of carbanion. And since it is a source of carbanion, it can act as a base as well as nucleophile. But when they are being treated with aldehyde, because aldehyde is having a electrophilic center, this is delta positive, this is delta negative. So CH3 MgBr as a carbanion would attack like this. So this would take this delta negative, this negative is going to attack it, and this would give you this thing. So as a consequence, what you able to get here is O negative. Along with it, you happen to get a counter ion as MgBr. So during the hydrolysis of it in acidic medium, so it will take this O negative will abstract H positive, resulting in the formation of a alcohol. And what alcohol do we get here is we shall be getting this type of a alcohol. Now here what you are able to see in this product formation, this compound which we have got is chiral, in the sense that this in a way is a chiral compound. Chiral in the sense that it is being attached, this carbon is attached to four different types of groups or group of atoms. Any compound which is having at least one chiral carbon would possess the um, condition of chirality, that it is optically active. Here, in this particular reaction, it may generate resin mixture also, but as a matter of fact, what the examiner is asking, the product do we get here in this particular question is chiral. It is not achiral. Achiral is the one where you miss the chirality, that there is no symmetry element available. There is some symmetry element available in a achiral compound. In chiral compound, there is no symmetry element available because all the four groups attached to the carbon is different. Now moving on to the second option. Second option is basically a carboxylic acid, and this particular reagent is a reagent for what you call it as HVZ reaction. That is what Helmholtz-Jelinski reaction. Helmholtz-Jelinski reaction. This particular reaction is the reaction where a a given carboxylic acid, if it is having some alpha hydrogen, it is basically a reaction where you should remember it like this, that any carboxylic acid if have alpha hydrogen and is being treated with bromine in presence of red phosphorus, it is going to do alpha halogenation. This is going to do alpha halogenation. So one of the hydrogen from here got replaced with the bromine. So not considering the fact that how this mechanism would have happened, so here what again you would see that you are going to create a carbon which has become chiral. So this chiral carbon is optically active. So here again the product which we get is not achiral, so it is chiral. So this would also not be our answer to the question. So here you have remembered one thing, that for HVZ reaction you must have alpha hydrogen available on the carboxylic acid, then only alpha halogenation would occur. Next part is the alkene is being treated with HBr. So what type of alkene do you have? This sort of alkene is there with you, and you have to treat it with HBr. So it is electrophilic addition reaction. So first I would attack the H positive here. So as a consequence, what I do get here is a carbocation, and the carbocation which I got is tertiary, and this tertiary carbocation is quite stable. And now as a matter of fact here, that Br negative now would attack this one. So as a consequence here, what I shall be getting at the last, I shall be getting this type of a moiety. Now this moiety is having two groups similar. So this ethyl group, and on this side also there is a ethyl group. So this compound is not chiral. This has become achiral. Achiral is the one where you would find two groups attached to the same carbon are identical, because it would have some plane of symmetry. So it would be optically inactive. So the point here is that the C option would be the right answer for our question. Now let us see the last D option. D option is having lithium aluminum hydride, as we have told you number of times that lithium aluminum hydride is a source of H negative, but it is a deuterated lithium aluminum hydride, and the one of the hydrogen is being replaced with the deuterium, so it is going to give me D negative. So the D negative coming from the lithium aluminum hydride would attack the carbonyl carbon. This is nucleophilic addition. So going on to this, you would get this type of a species O negative H. On one side you got D, and then in the second step, the solvent, which is water, acidic water, this water would give the H positive required for protonating this O negative. So you would get this as to be your answer. So you get OH, and here you have D. Now here again in this particular question, you would see that there is a generation of chirality, that the carbon has become chiral. So this in a way is a chiral compound. It is not achiral. So here we are through the answer that this particular option, that is C, this would generate a compound of the type this one, which is having two groups, that is ethyl groups common to it. This ethyl and this ethyl, both of these are common, so making it as achiral. So the answer to this question would be C. I think you have understood today's session. So we have learnt about few things, that Grignard, what is the reagent for HVZ, how lithium aluminum hydride adds, and lastly, what is the role of HBr while adding a cross to the double bond. Thanks a lot. Have a nice day. Stay safe and take good care of yourself.